Hello students, in this video we'll learn about formation of PN junction. When a p-type material and n-type material suitably join together, then they forms a junction at the point of contact, that is called PN junction. Here joining one p semiconductor and n-type semiconductor is not a mere contact. They use some manufacturing techniques to make this possible. Now, in this, we do not study about manufacturing technique, but we discuss about how a junction forms when a p-type and n-type semiconductor is fused together. For understanding this, let us visualize a p-type semiconductor. P-type semiconductor means positive type. We know that p-type semiconductor contains holes as majority carriers, electrons as minority carriers. Here in this diagram, we indicated holes as black circles, empty circles, and electrons as black thick dots. So the black thick dots indicate electrons and the circles indicate holes. In p-type semiconductor, holes are more because holes are majority charge carriers and electrons are minority charge carriers. On the contrary, if you consider an n-type semiconductor, electrons are majority charge carriers and holes are minority charge carriers. Now, when we join a p-type and n-type semiconductor, what happens? Usually in manufacturing, they take a pure semiconductor, intrinsic semiconductor as a substrate, and at one side they induce trivalent impurities, and the other side they induce pentavalent impurities, so that one side becomes the p-type semiconductor and the other becomes n-type semiconductor. Now, when these two are side by side, then what happens? Here you can see on n side, majority charge carriers are electrons. Electron density is more here. It is just like a gas. When you open a perfume bottle in a room, perfume spreads throughout the room because the density of perfume molecules inside a bottle is more compared to the room. So it easily diffuses throughout the room. In a similar way, here the density of electrons on n side is more compared to p side. So these electrons easily diffuses through the junction towards the p side. In doing so, what happens? They combines with the holes here and there, everywhere. So we know that electrons are negatively charged and holes are positively charged. So this is called electron hole combination. This makes a depletion layer or barrier potential formation. Look at here. So here we now understood that when an electron jump towards the p side and joins with the hole, here n side has lost some electron. When these atoms lost electron, they becomes positively charged. In a similar way, on p side atoms they have gained one electron. When they gain that electron, they becomes negatively charged. Because of this reason, a series of positive and negative charges accumulated at the point of contact or junction. This is just like positive charge on one side and negative sides on other plate, like a cell or battery. We have positive charges on one side and negative charges on other side. So it just acts like a cell or battery. And as the charges are accumulated, it definitely possesses some potential. We call that potential as barrier potential. Why we are calling barrier potential means when this barrier potential is formed, then the electron which is present on n side cannot easily go and join to p side. So the diffusion of electrons from n side to p side reduces because of this barrier formation. That is why this is called potential barrier, and the voltage across this is V naught. Let us say it is called as barrier potential, and this region is also called as depletion region because it no longer contains free charge carriers. That means here either electrons or holes are present. No mobile charges are present. No free charges can move are present in this region. It is depleted of charge carriers. That is why it is called as depletion region. And we have just discussed that when this potential barrier is formed, then the electrons no longer diffuses to p side because they have to overcome this potential to join on p side. So this diffusion decreases. The current due to diffusion of electrons diffusion of electrons is called as diffusion current. Here I indicated with I diffusion because because electron cross from n side to p side, the current direction is from p side to n side. I mean to say left side to right side. This is the direction of majority charge carriers or diffusion current. Now we know that when the potential barrier is formed, the diffusion current is very less. But not only electrons here on n side, we have also small minority charge carriers, holes are there. And on p side, a few number of electrons are also there. So these electrons on p side, they come and drift towards n side and combine with holes to give a small current called as drift current. Drift current is due to minority charge carriers. And here we can see a small amount of diffusion current as well as drift current. But when an equilibrium state is attained, then this drift current and diffusion current both are equal and no current passes through junction. Sorry, the net current passing through junction is zero because drift current and diffusion current both are in opposite direction and at equilibrium they are equal. So a stable junction with no net current is formed. This junction is called PN junction. It has so many applications in different areas. This is the main building block of many electronic devices. We will discuss about these applications in the next videos. Thank you.